So we have the innervation. Oh, let me share. Oh, let me share. So we have the innervation to the hand, and we said that the innervation differs. That's what we said the other time. So we have got this palm. This is called the palm, and then we've got this dorsum, the other side of the hand. And we said when it is facing like that, then let me not talk about that. So let's just know that we've got this side which is innervated by the median nerve, in the median nerve. That is why there is claw of the hand, not claw of the hand. There is what you call Epi's hand in the median nerve injury. This side, so there is tingling and numb. I don't know how to pronounce that one, caused by the median nerve injury. So the median nerve, we know that we've got the first, the thumb, the index finger, we've got the middle finger, and also the ring finger. These you divide the ring finger by 2. Ooh, you divide it by 2. So meaning that the half coming this side is innervated by the median nerve. So with the exception of this one, the little finger and the half of the ring finger, these ones are innervated by what? The ulnar nerve. So the ulnar nerve is this side, while this side is the median nerve. Again, if you come to the other side, the dorsal part of the hand, this side is the radial nerve. So meaning that this radial nerve is more like on the opposite of the median nerve, which is on the other side, and then it is cutting the middle finger packet on the middle there. Boom, it cuts there. Then you have got the red part, which is innervated by what? The ulnar nerve this side. So in short, what we're trying to tell you is that you people know the innervation of this hand in this manner, in the way this thing is. Same things here. Rib cage, vertebral column. So the radial nerve injury is called wrist drop. You know that. Talked about that. So these are the seats, the rotator cuff muscles. You've got the supraspinatus, teres minor muscle, and subscapularis muscle. Constrictions of the esophagus, very important. Very important. The first one is at what you call the clycopharyngeal sphincter. This is where the cricoid cartilage is. So now it's the one that, no, not the cricoid cartilage, but the pharynx. That is the first constriction. The second constriction is on the aortic arch. So here. The first one is there. Upper sphincter, on the upper sphincter, this side, on what we call the clycopharyngeal sphincter, which is here. So you've got what you call the esophagus. There's what you call upper esophageal sphincter, lower esophageal sphincter. So the upper one is also called the clycopharyngeal sphincter, which is 15 centimeters from the incisors, which are the teeth of the. Let me just put it in that manner. But just know that the upper esophageal sphincter at C6, that marks the first constriction of the esophagus, and that anatomical is normal. It's not abnormal. It's just there naturally on the sphincter. The second one is where the aortic arch crosses. You've got the aortic arch which crosses are on the trachea there and also the esophagus, laterally here on the left side. So that is the second constriction. The third one is where crossed by the bronchus, the left bronchus to be specific, which is here. You're able to see it there. So it's crossing there. It's crossing there. I think the Zambia national team has scored there. Okay. So where is it closed by? Okay. The last one, the fourth one, is when the esophagus is just entering the stomach. It's called the cardia. So when it passes through the diaphragm, there is also a constriction. So in short, you need to know all these constrictions, because I saw an MCQ question concerning that. So you need to know that there are 4 constrictions on the upper esophageal sphincter, lower esophageal sphincter, where it crosses with the aortic arch and also the trachea. But to be specific, the left bronchus, which is this one here. Okay. So we've talked about these constrictions, and they're there. Constrictions again. Constrictions. Okay. talked about that. That is the leg. This is the diagram that came in your paper. This is embryology, constrictions. We've talked about them. So in here, I think they are regarding them with different names. There's what we call diaphragmatic constriction, meaning that as it is entering the diaphragm, we've got in the thoracic, where we have got aorta bronchial, meaning that the aortic arch, and also the bronchus. Okay. The first one is called pharyngoesophageal constriction, meaning the first sphincter which is on top there, just below the mouth, so to say, just below the mouth, where the esophagus starts from. There's a sphincter which prevents the food from going in there. So that is also the first constriction. So at auscultation, I've got the angle of velocity, which is between the T4 and the T5. Okay. Okay. Anyway, it's not very important for now. It is not important. I don't know, that is not important too. You've got this art. So you need to know this diagram properly. You've got the aorta there, you've got pulmonary artery. We have two pulmonary arteries, remember, we've got the left and the right one. And then you have got what we call the veins, which are 4. We have got 2 this side and the 2 that side. So this side is called the right pulmonary veins. This side, because this art has been like, it's been, how can I say this? It's not in the anatomical position. It's been turned. So this is the posterior aspect of the heart, where they are saying left atrium, meaning that you don't have to change the side. So the right will remain the right hand side, or your right hand side, while the left will be the left, like that, because this heart has been turned. So it is not in anatomical. It is in anatomical position as you are seated there. The way you are facing it, I don't know if you are facing it in that manner, but all I know is that this side, that's where my right hand is. So know that diagram: atrium, inferior vena cava, right ventricle. This one you need to know it, because I even sent it in the other. So azygous vein drains on what we call the superior vena cava, which is here. Do you know that this is disturbing? So if the superior vena cava is here, meaning that the inferior vena cava is supposed to be down there. Okay. And then you have got pulmonary veins, 2 pulmonary veins this side. You have got pulmonary artery, which is there. Aorta is very big, so it's called aorta is there. Okay. So it is important to know that. So know this diagram properly. Know it. So this is the same diagram that is here. You have got the left pulmonary artery, you have got right pulmonary artery. This one will come in your paper, I'm telling you. You've got the ascending aorta here. You've got the aortic arch, which I said it has 3 branches. Here they can label it. This is called bronchocephalic trunk, left common carotid artery, left common carotid artery, and left subclavian artery. And then you've got the superior vena cava. You've got the inferior vena cava, which will be down there. If you have got the superior, meaning you're supposed to have the inferior down there, which is here. And no, these are veins. These are called pulmonary veins, and you have got 4, 2 this side and 2 the other side. So these are called right pulmonary veins. These ones left pulmonary veins. And know the other thing, descending aorta is coming this side, because there is ascending somewhere, there should be descending somewhere. So you need to know that diagram very well. And it is also in that PDF that I sent in the morning, which has questions, diagrams. And I think that's what we'll go through again, the diagrams, because we are done with this one. So let me just transfer that one. I think it's there on the piece. Let me just download it. This one, this is the conduction system of the heart. So this is the conduction system of the heart. This is what Mona has been looking forward to. So in the conducting system of the heart, or what is happening is that there is electricity happening that side. This electrical activities is the one that triggers the contraction of that mass that we have, the heart, the myocardium. So for the myocardium to contract, you need this conducting system of that to be activated. Okay. So the first things first, you have got what we call SCA node, which is called sinoatrial node. After sinoatrial node, you have got what we call the AV node, which is called atrioventricular node. So sinoatrial node, atrioventricular node. From there, we've got what we call the band of ease. The band of ease. From the band of ease, we have what we call the band of branches. From the band of branches, we've got what we call Purkinje fibers. From the Purkinje fibers, they move, they ascend. Now, let me annotate. Let me try to explain more on these ones. On these thingies. Okay. Let me talk about this. I want to. What is the new share? So, in case they ask you, because this question is very common in medicine, maybe they will ask you the flow chart just. So it's very simple. Just say sinoatrial node, atrial node, which is the first one. Sinoatrial node. From there, you have got the second one. Okay, let me write it down. So I've got the number one there. We'll put that one as a number one. We've got number two, which goes into the AV node, which is called atrioventricular. Arterioventricular. Ventricular. Atrioventricular node. From there, what we call the bundle of ease. The bundle of ease. The bundle of ease. The bundle of ease. From the bundle of ease, we have what we call bundle branches. Bundle branches. Bundle branches. From the bundle branches, we have got what we call the Purkinje fibers. Purkinje fibers. Purkinje fibers. From there, they ascend. They go, they get distributed. Get distributed. So these are this summarizes everything about the art or conducting art system. How does the electrical activities move from the sinoatrial node and find themselves in the muscle fibers and cause muscle contraction? This is what I'm trying to. This is what I'm going to talk about exactly. So let me go back to my sharing. I just wanted you to write down this. Know this one very well. Where is it? So know all this. This is the how it flows from the sinoatrial node, which is the SA node, to the AV node. From the AV node, the band of ease. From the band of ease to the band of branches. From the band of branches to the Purkinje fibers. That is where it ends, and then it goes back. So let me just explain that now. Okay. Are you able to see my art? That's the question.
No, we can't.
You can see it now.
Yes.
Thank you. So here where is my pen? So here, when you come here, that's why the SA node is. The SA node, which we said is the sinoatrial node. So the action potential starts from there. And remember, you are going to learn that the art performs the action potential, or it produces. It has got two types of cells. There's what we call nodal cells, and also the other cells, which plays their roles in the in what we call autorhythmicity, whereby the art is able to produce its own action potential from those cells. Non-nodal cells should be, I don't know the other type of cells, but there are two types of cells: the nodal cells and the one that produce, and the other ones which produce action potential. So the action potential will be produced in the SA node. Remember, we talked about the action potential, how it is produced by the sodium what, calcium what, but this one is different, which we'll talk about in physiology. But just know that there is action potential produced from the SA node. From there, it moves. There are projections which projects in this direction. Let me just annotate again. There are projections which connect this one into this one. There are projections which come like that. So these projections, they are the ones that transport that action potential from the SA node and transport it to the AV node. When the action potential reaches that site, there's what we call AV node, which is there. Atrioventricular node, it is there. So that node is also produces some action potential, and adds. It's more like it is just adding, supplementing whatever the SA node did. And they say that when the AC node is malfunctioning, is not functioning, the AV node can play a good role by providing the compensatory mechanism by doing the same things that this one was exactly doing, but this one produces more action potential than this one, the AV node. So most of the times when they say the art is malfunctioning, meaning what happens is that these nodes are not working, they're not producing the action potential, and the art is not contracting, because for the muscle to contract, you need the action potential. So the action potential moves from the AC node, to the AV by these projections. From the AV to it will move to the band of ease band, from the band to the band of ease. So there is a connection. You've seen, you're able to see it. So when it reaches there, from there on the band of ease, there are those band of ease, if you're able to see them properly, they are branching into two. There's this one and this one. So both of them are branching. And remember, we said at each node there is production of action potential, but most important is the ASA and the AV node. And then those action potential will move. As they are moving, this is more like this is a mass. This septum is more like a mass. So they start contracting. So when they move, the band of ease, band of branches. From the band of branches, they bifurcate. This one goes on the left, this one goes on the right side of the heart. And remember, this one is thinner. The right side of the heart is thinner because it doesn't pump blood at high pressure. This left side is thicker because it pumps blood at high pressure. And that's why the more projections are going. That's why these Purkinje fibers are going. So that they produce or they take the action, more action potentials that side. So that there's more contraction on the right side, or sorry, on the left side of the heart. So just know that you've got SA nodes. From the SA node AV to the band of ease, or ease band. From the band of ease, they are branches, so you call them band of branches. From their band of branches, you got what you call Purkinje fibers. Purkinje fibers are the ones that will innervate the ventricular muscle and causing the muscle to contract. Are we together?
Yes, Doc, we're together.
Thank you. So we are done with the conducting system of the heart. And that's the end of these slides. The passing anatomy. We are done with them. So we are going to the diagrams that I sent in the morning. We just revise them and then it ends there. So thank you so much. You can just log out and then log in again for the next session, which will talk about the diagrams, and then we will end there. We'll do the whole diagrams that I sent in the morning in the group. Thank you.